Everybody, it's Tyler here at Space City, checking in with 231 and KNIGHTS Robotics. This robot has a lot of great creative features on it that we'll be focusing here on Pits and Parts. A couple things that we really want to talk about here. You got to check out this lifting intake that they have, but not just that, but how they're actually meshing their gears when it comes down here. One of the most unique things I've seen on a robot so far as well. A lot of great stuff. I love their overall build quality that they're doing with this robot. We're talking about how they're able to score over the mobile goal and the wall stakes as well too. So a lot of great strategy that's gone into this robot. Let's learn more about them coming up here on Pits and Parts. Javier, let's take a look at this drive here. When you and I were talking before, you're going with a little bit different motor config than what a lot of teams are using, so talk to me more about it.
All right, so usually people use the other blue motors, but we don't use blue motors, we use the other 300 RPM motors because most people use those motors for speed and everything, but we chose an easier route only because the fact that we want more speed, but at the same time, we also don't want to burn up our motors too fast. So the main problem we have with it is that we haven't had any breakdowns or nothing with it. It's not really a problem, but the only problem I think we've had was our air tank on the side hitting one of the gears down here, but we fixed that problem a while ago. So it's kind of a small error we had, but it's nothing too major.
So when you're gearing up for speed, though, you do sometimes sacrifice torque out of doing that as well, too. How did that payoff work out for you? Like when you're looking at mass strategy, why was that the right way for your team to go?
Well, it was more so the fact that we wanted to make sure our robot would be stable enough to compete and go against other robots head-to-head in a push-off. Let's say we're getting defended, heavily defended on our robot, we want to make sure we're okay enough to keep scoring and not get our goal taken out from here, but still having enough power to keep it pushed into the corner without having anyone take them out.
Thomas, let's talk about this arm overall on the robot. I mean, overall just going with more of a squish wheel aspect of it, but going up and in, and the way you're scoring on wall sticks is really interesting. So talk to me more about this whole structure here.
So throughout the whole season, we noticed that a lot of people have the same type of design of a chain system with hooks. So I saw one team, I forgot the number, but they inspired me to create this type of intake, which actually lifts all the way up. As you can see, it goes all the way up and is able to score on the high stakes as well. Our intake, it goes from 2 5-watt motors to 3 5-watt motors because of the gear meshing that we have on the bottom. So this is one of the key things with my intake is that I'm always gonna have enough power, either grabbing rings from the floor or grabbing rims or pushing the rings all the way to the top to the goal. And our gear ratio and our RPMs, we go from 400 to 200, and we go from 400 to 200 just for the purpose of having enough torque to push this up, which helps us again load the ring into the mobile goal. So our arm is kind of key also with our strategy, which we're going to be talking about later on.
So a couple things I want to follow up with that on, with the gear meshing that you're doing, first off, when you were designing this robot, how did you even come up with you want to do that? And do you have any issues with any gear slippage or anything when those come back together?
So I've been having a lot of issues with it, and I knew this was going to be a cost of having this type of design, but how we designed the robot, it is very common, but good thing we have 2 of them on each side. So let's say that the arm does kind of bend a little bit or twist, there's always one gear touching the other gear, which has saved us multiple times.
The other thing I want to ask you too, some of the other teams we talked to that have done this kind of lifting intake, so to speak, most of them just kind of go straight through with their ring, but you almost have implemented kind of like a hood almost on the end as well too. Have you seen that that's really helped you be more successful in scoring on wall stakes?
On wall stakes, it's a little bit tricky, but with practice, anything can be done. I think I've been perfecting my high wall stakes, even my alliance side, but yeah, it's been an issue, but I think I want to have a design that could also score from the mobile goal to the wall sticks as easy as possible.
Can you show me how that process works with bringing one in and how that lifts up?
Intake. Okay, stop.
Let's talk about this bottom intake. We mentioned a little bit about it, but I see a little bit of compliancy on it. There's obviously a lot of great design that goes into it. Tell me a little bit more how that functions.
So the bottom intake functions with the top intake, again with the gears, but we also have a different gear system from the top. We go from a 200 RPM on a 5-watt motor, and we gear it down to a 12. So a 24 to a 12, which goes to 400 RPMs. From the bottom, it goes 400 and it goes up to 200. One of the things with our top intake is that the amount of friction we have and the material selection kind of is important to us because we tried different materials and we got a lot of friction. So one of the major things that we focus on the top intake is having not a lot of compression in between the wheels and the plexiglass or the plastic. And another thing is the perfect spacing. Our rings fit perfectly inside of the intake to the point that there's always going to be at least one wheel touching the rings at all time.
So looking at going from a squish wheel versus like some of the belt intakes I've seen out there, did you just find that overall that you're just able to get more contact on it, or like what was the overall benefit for you going squish wheels?
I think the benefit was of having, again, more contact, which I think I'd rather, now that we're later on into the season, I think a chain system works better. But at the beginning, I think this was working really good for me, and it still has been working good to me. But again, I like having more contact over speed. This is accurate. This can score when I want to score.
Well, obviously, as we're filming this signature event, you're doing phenomenal so far, so it's got to be working out pretty well for you. As we start to wrap up, talk to me a little bit about some of your match strategy, how you are approaching here at Space City, and maybe do you see that match strategy evolving throughout the process here at Space City for you?
So some of the strategy that this robot is really good at is able to score in the high stakes while still holding on into a goal. I see a lot of people that are able to hold on to a goal but not being able to do high stakes, ball stakes, my bad. And this robot could do them easily. So let's say that we're in a match where all the goals are already filled out. People are just grabbing goals, throwing them to the negative. I don't want that. I want to keep my goal with me at all times. So I have possession of it, but I also still want to be able to score more points. So this is one of our major strategies with this robot, is that we can still be scoring while still containing our goal.
Yeah, all offense, baby, right? So
Yep.
I feel it. So, hey, 231N, thank you so much for taking time to tell us more about this machine. I love the design overall. A lot of great iterations you've gone through. And, of course, we wish you best of luck here at Space City. So thanks a lot.
Thank you.